Let's explore gravity. You are going to investigate if the acceleration due to gravity is the same across the solar system. You will need the following equipment: access to the NSO's online gravity simulator and a stopwatch. You may also want to download or print our worksheet. Links to the worksheet and simulator are included on the activity webpage. Before you start, you need to plan your experiment carefully. What will be your independent variable? This is the thing you change, and it has a direct effect on the results. What will be your dependent variable? This is the effect that you measure. So you have decided what your independent and dependent variables are. The other things you could have changed are your control variables. You must keep these the same each time, otherwise they could affect your results and the test won't be a fair one. Drop the ball from your set distance and measure your dependent variable. Repeat your measurements several times and record your results. Try to be as accurate as possible. When you have repeated the test a few times, you can work out a mean average time for that location. Then repeat the experiment for each of the locations. Our investigation is to find out if the acceleration due to gravity is the same across the solar system. From your results, you will work out an average time for each location. You also know the distance the ball travelled, which was the height you dropped it from. For an object like our ball travelling in a straight line with a constant acceleration, we can use the equations of motion to find the acceleration. Here comes the maths. This equation of motion tells us how to calculate displacement. Displacement is the change in position in the object, in this case the total distance the ball travelled. We are interested in finding out the acceleration, so we can rearrange this equation to make acceleration the subject. If we assume there is no air resistance and no other downward force, the acceleration A is equal to the acceleration due to gravity G. So for this experiment, we can replace A with G in the equation. Since the ball has no initial velocity, u equals 0, and we can simplify the equation. In this experiment, we are dropping the ball from a height, and this is our displacement. So S becomes h, our drop height. Don't worry if you didn't follow all of the algebra just now. This equation is the only one you need to use. The acceleration due to gravity is equal to 2 times the drop height divided by your average time squared. Use your results in this equation to complete part 3 of the worksheet. The worksheet also includes some questions to help you think about your results. You may want to discuss your answers with others. But most importantly, have fun.